I'm going to get started. We are still factoring. I'm trying to do it so that each day when we're factoring, I show you something new, just to kind of take it slow, because there's lots of moving pieces when it comes to factoring. So I'm trying to just show you one little new thing at a time. So I've come up with a list of important reminders that I want you guys to be aware of. I've talked about two of these, and then one of them's new, all right? And then I'm going to end by showing you a special kind of factoring case called the difference of two squares. And this is what your homework is going to concentrate on, factoring the difference of two squares. Okay, well, let me just go back to these important reminders really quick. A couple of things that I always want you guys to be aware of. Number one, I have said it since the first day, you are always looking for a GCF first. Always look to factor out a greatest common factor, right? Two reasons. Number one, because the directions are going to ask you to factor completely, and it's not factored completely if you don't take the GCF out. But number two, the reason why you would want to take a GCF out is it should make the problem easier and smaller to work with. So it should only help you factor it. 12 minutes, buddy. Okay, sorry, my son is counting down an update on Roblox, and it's very exciting. So I apologize. Yeah, do you want to show them your dance moves real quick? These different hit him with a move real quick. It's different class. Oh yeah. Okay. Yeah. Get him some music, guys. Awesome. You're so good, Zach. Awesome. Okay. Mom, it's the Guardian Lion. The Guardian Lion on Roblox is supposed to come out today, guys. And the Ox. And the Ox. It's a big day, okay? And there's a brown pet again. A brown pet, but it's the Golden Lion, guys. No, it's not. It's a red and orange lion. It's a golden red lion. Okay, all right, guys. Z-Man, Z. It's a Chinese slanted one. Okay, buddy. Chinese update. You have to go upstairs with that. Let me finish this. I have to get through this, but we are just as excited as you. Don't worry. Okay, here we go. So number one, I hope you're looking for that GCF, because like I said, the problem's going to ask you to by saying completely. And number two, it should make the problem easier to work with. All right, the next important reminder. If the expression leads with a negative number in front of the x squared, you must factor the negative out with the GCF or as the GCF. So guys, I've talked about it before. Like when we're looking for the GCF, normally I say, don't worry about the signs. Just find the GCF. The only time you would factor out a negative is if the expression led with a negative. Like see how that number in front of the x squared term, it leads with a negative, then you would factor it out because they don't consider it to be factored completely if you leave that negative sign in, if the problem started with a negative, okay? And then the third important reminder, I want you guys to understand that sometimes you need to rearrange the terms to be in the ax squared plus bx plus c form that we like the problem to be in. So look at example 2. This is not the order that these terms should be written in when we go to factor it. The x squared term should come first, then the x term, and then the number should be last. So sometimes you might have to rearrange some things before you go to factor it. Okay, so let's give it a try. Let's look at number 1. Let's say you were asked to factor this expression completely, right? Okay, well, first I would look for a GCF because I always do. What does an x squared, a 12x, and a 45 have in common? Normally you would say there is no GCF. The biggest number that divides evenly into a 1, a 12, and a 45 is 1, so that doesn't count. They don't all have a variable, so there's no variable they have in common. Therefore, the GCF is not there, which is true. But because it leads with a negative, we're at least going to factor out that negative sign. So we're going to factor out that negative sign and then get a new expression that is left once you take that negative sign out. Now, guys, luckily, you're basically factoring out a -1. So the only thing it's going to do is affect all of the original signs. All of the original signs should become the opposite when you factor out a negative or a -1. All right, so think about it. A negative times a what gets you back to a negative x squared. An x squared term, right? So see how the sign is the opposite than the original? All right, a negative times a what gets you back to a positive 12x? A negative 12x, right? See how the sign is now the opposite from the original? And then a negative times a what gets you back to a positive 45? A negative 45, right? See how the signs are the opposite. Okay, so we factored out the negative sign. Now, like normal, we'll bring that GCF down, and then we'll look to take our new expression and factor it again, okay? Now, guys, just to warn you, in the future, sometimes this expression, this new one, does not factor again, which is fine. We'll just have to leave it like that, but I'm not assigning those ones yet. I want everything to factor so you can practice, okay? All right, let's do it. So now I know whatever I put here and here better multiply to x squared. Well, guys, we've already agreed that we're going to use an x and an x to get us that x squared, right? And then I know whatever numbers I put here and here better multiply to that last number, negative 45. So remember, if you're going to multiply to a negative, you're going to need your numbers to be different signs. One number will be positive and one number will be negative. Okay, well, since my numbers have to multiply to negative 45, give yourself some options. What numbers do you know multiply to 45? 1 and 45, 3 and 15, 5 and 9. And since it's just an x and an x, I know it doesn't matter where I put them. And I know I'm trying to get my rainbows to get me those negative 12x's. So guys, if these are my options and I know where I put them doesn't matter and I'm trying to get a negative 12x, then I'm looking at that 3 and 15 right away because it looks like they could get me a 12. So in any order, let's put a 3 and a 15. And let's see if we can get the signs to do what we need them to do. All right, my rainbows are going to get me 3 times x, 3x, x times 15, 15x's. Can I make a 3x and a 15x get me that negative 12x? I think I can, especially when I know my signs have to be different. So in order to get a negative 12x, I would need a positive 3 and a negative 15x. Let's put the signs in and check our work. All right, if I need a positive 3x, this would have to be plus, and I would need a minus there to get negative 15x's. Let's check to see if everything's doing its job. Does x times x get you x squared? Yep. Does positive 3 times negative 15 get you negative 45? And do your rainbows, 3x's and negative 15x's, get you that negative 12x in the middle? Yeah, they do. So everything works. So these are definitely your factors. So this is what you would say is your final answer right there. Okay, can I get a thumbs up if that felt okay, pulling that negative sign out first and factoring? All right, awesome. All right, let's look at number 2. Number 2, right away, you should notice that these terms, these pieces, are not in the correct order. We want the x squared term, then we want the x, we want the just number at the end on the right. So let's rearrange everything. So don't lose your signs, though. Let's put the negative 6x squared first, because he should be first. Let's put the negative 2x's in the middle where the x's always go. And then let's put that positive 28 at the end. All right, just make sure you don't lose their signs when you do this. He should still be negative, this should still be negative, and 28 should still be positive. All right, if I have to factor this, right away, your brain should be saying, look for a GCF. What does a 6x squared, a 2x, and a 28 have in common? Guys, they have a 2. Their greatest common factor is a 2. They all divide by 2. So I'm going to pull a 2 out as my GCF. But wait a minute. It led with a negative sign. So instead of pulling a 2 out as my GCF, make it a negative 2. Make that negative sign part of your GCF. So let's pull out a negative 2 and see what's left. All right, what's my new expression now? So negative 2 times what gets me negative 6x squared? A positive 3x squared, right? And see how this term used to be negative, but now he's positive? Because pulling that negative out should make all the original signs the opposite. All right, negative 2 times what gets you a negative 2x? That would be a positive x, would make that happen. And then negative 2 times what gets you a positive 28? A negative 14. All right, so I've pulled my negative 2, my GCF out. Now we bring it down and we take that new expression and we try to factor it again into 2 more pieces. All right, let's work our magic here, right? I know whatever I put in the first 2 spots has to multiply to 3x squared. Well, guys, we know we're going to use x and x to get the x squared. Now what am I going to use to get the 3 as part of the 3x squared? Well, guys, lucky for us, the only 2 whole numbers in the world that multiply to 3 are 3 and 1. So we don't have a lot of options. The only options we have are a 3x and a 1x to make that 3x squared. So that's what we're going to use, a 3x and a 1x. So now, since one of my x's has a number in front, I know that's going to matter where I put the other 2 numbers because it's going to affect my rainbows. All right, so just be careful, and we're going to really make sure we work those rainbows to make sure everything's doing its job. All right, I know whatever numbers I put here and here have to multiply to negative 14, right? So again, if I'm going to multiply to a negative, I know my signs have to be different. One number must be positive and one number must be negative. So keep that in mind. All right, well, if numbers have to multiply to 14, give yourself options. What numbers multiply to 14? 1 and 14, 2 and 7. Guys, pick your favorite ones throw them in, start working those rainbows, and start guessing and checking until you find the combination that works. All right, I'm going to try the 2 and the 7 first. I told you guys that once you've taken a GCF out, you should never create a factor that has a GCF. So it's safe to try the 2 here because it's not making a GCF between the 3 and the 2. So it's okay to put the 2 there. Let's try the 7 there. Let's see what my rainbows are telling me. 2 times x is 2x. 3x times 7 is 21x. Guys, are 2x's and 21x's ever going to get me a 1x in the middle? Nope. So this is not right. So before I say the 2 and the 7 are not correct, switch them. Let's try the 7 here and the 2 over there and see what that does to my rainbows now, right? And it's okay to put the 7 here because a 7 and a 3 do not have a GCF. So it's not like I'm creating a factor with a GCF. All right, now what do my rainbows do? 7 times x is 7x. 3x times 2 is 6x. Could a 7x and a 6x get me a 1x? Guys, I think they could, especially when I know my signs have to be different. Who has to be positive and who has to be negative to make this happen? Well, in order to get a positive 1x, I would need a plus 7x and a minus 6x. Let's throw our signs in and check our work. All right, so to get a positive 7x, I would need a plus here. And to get a negative 6x, I would need a minus there. Let's check. Does 3x times 1x get me 3x squared? Yup. Does positive 7 times negative 2 get me negative 14? Yup. And then do my rainbows, positive 7x and negative 6x's get me the 1x I need in the middle? Yeah, it does. So guys, everything works, and these are definitely your factors. Just don't forget that GCF is part of your answer. All right, give me a thumbs up if that felt okay. Everybody still feeling okay with these factoring? Yes? Okay. All right, I'm going to ask us to skip number 3 today. I don't want to go over that one yet. Let's go down to these difference of 2 squares. All right. Now, guys, when I say the difference of 2 squares pops up all the time in the future, it does. In pre-calculus, when we are working with these higher degree equations, perfect squares, they pop up all the time. So you want to be able to be really good at recognize it when they are there and then factoring them. Like I'm telling you guys, factoring these is very nice because it factors the same way every single time. You shouldn't have to think as hard to factor these ones, okay? All right, so what I guys want you to think about is when you factor the difference of 2 squares, I don't know if this is going to help anybody, but I want you to think in your head, I need things to be matchy when I go to factor. You want your factors to match. Whatever you put in the first parenthesis and the second parenthesis, they should be the same things both times. Everything should be matching, okay? Now watch this. So what is the difference of 2 squares? The difference of 2 squares looks like this. When you have a square, x squared is a square. He's x times x. He's x squared. And you are minusing or subtracting, because that's what difference means. It's a fancy word, subtracting. And you are subtracting another square. Guys, 16 is a square. It's 4 times 4. It's 4 squared. You need the same number times itself 2 times to make this number. So 16, guys, is 4 squared. He's a perfect square. All right. 25 is a perfect square. He's 5 times 5. He's 5 squared. 36 is a perfect square. He's 6 times 6. He's 6 squared. These are numbers that you could take square roots of and get whole numbers back. So if it's the difference of 2 squares, it has to be a square subtract a square, just like this. And then watch how they factor. All right. Well, if I'm going to factor this, first, just to go through the motions, I would look for a GCF. But an x squared and a 16, guys, they don't have a GCF. So we are going to factor it just the way it is. So since it's the difference of 2 squares, I need these factors to match. Whatever I put here and here to multiply to x squared, guys, it's got to be the same thing. I have to match them. Well, lucky for us, what are we already using to make that x squared? An x and an x, okay? They match. I'm using the same thing in both parentheses to get me that x squared. All right, whatever number I put here and whatever number I put here to get me that 16, guys, it's got to be the same number. They have to match. So what are the only same numbers that multiply to 16? 4 and 4. So see how your factors match? They have to match. This is the only part that won't match. The signs. If I'm going to multiply to a negative 16 and then get my rainbows to add up to 0 x's because there are no x's in the middle, then what do I need? I need opposite signs. One number has to be positive and one number has to be negative to do this. And that's how the difference of 2 squares are always going to factor. They're going to factor to the same 2 parentheses, except one will get a plus and 1 will get a minus. And now check. X times x gets me x squared. 4 times negative 4 gets me negative 16. My rainbows get me a positive 4x and a negative 4x. What do a positive 4x and a negative 4x add up to? 0 x's, just like the 0 x's that this problem had in the middle. Does that make sense? Everybody see how everything is matching? It's got to be the same things when you go to do this, okay? So to me, it takes a lot of the guessing out because you know that the numbers have to be the same. So you're only allowed to use things that match, that multiply to the things that we need them to multiply to. All right? Okay, let's try it again. All right, so guys, let's say they asked you to factor x squared minus 49. A couple things. Number one, I hope you get good at recognizing like, oh my God, I think that's a square minus a square, right? Another thing that should stick out is that, guys, these are tiny expressions. They're not your normal three-piece expressions. Your x squared, your just x's, your just number. These ones are always missing the x's in the middle. They don't have x's in the middle if it's the difference of two squares. All right? Well, just to go through the motions, we'd still look for a GCF. What does an x squared and a 49 have in common? Nothing. They don't have a number or a variable in common. So we're stuck factoring it just the way it is. So then again, I hope your brain says, I think this is the difference of two squares. It's a square minus a square. 49 is a square, guys. He is 7 times 7. He is 7 squared. All right, so let's do it. So what can I put here and here that multiplies to x squared and matches? X. All right. What can I put here and here that matches, that multiplies to 49? 7 and 7. And then what do I always need my signs to be to multiply to that negative number? And then to get my rainbows to add up to 0, I need 1 to be positive and I need 1 to be negative. Because if you're going to add up to 0, guys, you definitely need opposite signs. Only 7 and negative 7 will add up to 0, right? You need opposite signs to do that. All right. Does that make sense? Is everybody okay with that one? Okay. All right, look at the next one. Look at number 6. Let's say they asked you to factor this expression. So right away, I hope you get a little excited, like, ooh, he looks small. He's missing those x's in the middle. Is this the difference of two squares? I want you guys to get really good at looking for them and recognizing them, because if you can recognize them, hopefully they start to factor really, really fast for you. But unfortunately, you should pump the brakes and go, wait a minute. 2's not a square. There's no number times itself twice that gets me 2. The only numbers that multiply to 2 are 2 and 1. 2's not a square. Guys, 18 ain't no square. There's no number that I could times by itself twice to get 18. Numbers that multiply to 18 are 1 and 18, 2 and 9, and 3 and 6. So this is not the difference of two squares. But we're not going to panic yet, because what do we always look for first? A GCF. And what does a 2x squared and 18 have in common? A 2. Take out a 2. And again, I'm not going to make it a negative 2 because this did not lead with a negative. So there's no reason to make my GCF negative. All right, if I pull out a 2, what expression is left? 2 times what gets me back to 2x squared? A 1x squared. 2 times what gets me back to negative 18? Negative 9. All right, now just like before, we'll bring our GCF down. We'll take our new expression and we'll try to factor it again. Now, I hope your brain gets a little excited, like, oh my God, I think this is a square minus a square. It's the difference of two squares. So to factor it should be pretty quick. Whatever I put here and here has to match and multiply to x squared. X. Whatever I put here and here has to match and has to multiply to 9. 3 and 3. And then what are my signs always going to be to multiply to that negative 9 and then get my rainbows to add up to these 0 x's in the middle? I need 1 to be plus and I need 1 to be minus every single time. And then does everything work? Does x times x get you x squared? Yup. Does 3 times negative 3 get you negative 9? And do 3 x's and negative 3 x's get you the 0 x's in the middle? Yes, they do. So again, I'd like to think the difference of two squares are better because it takes a little bit of the guessing and checking out, because you know whatever you use has to match. Is that okay? Everybody all right? Everybody good? All right, well, what I'm going to do is, guys, I actually want to do one more with you. I'm going to create an example 7 because when I went to create the Delta Math homework, I noticed they were putting ones like these on a few. It came? Is it just as good as we thought? Yes. Awesome. I'll be right up, bud. I'll check it out. Yeah, bud.
Mine's legendary.
Oh, it's legendary?
I already got 2 Luno. I'm trying to make a neon ultra whale one.
Get it. Let's go.
No, but Mom, the Goni mine's legendary.
Oh,
so
we like legendary.
I know. I'm trying to get it. I'm trying to get it.
Does any of you guys, do you guys know Roblox? You have to know Roblox. I know you guys know Roblox, right? This had to, this thing? I don't know. Okay. All right, here we go. So let me try this one because I did notice that Delta Math was putting ones on like this, and I don't want you guys to be thrown for a loop. What if they gave you this one? What if you were asked to factor 25x squared minus 81? So again, my brain right away goes to, it's Adopt Me. Yes, it is. Oh, Mackenzie, he asked me. My son has been counting down this update that was coming out today. Oh my God, I'm sure your brother was talking about it. See if he got the golden lion. All right, here we go. I want you guys, first of all, my brain goes, dude, 25x squared and 81, these are huge numbers. So right away, just the size of the numbers might throw you off, but don't panic. Just like normal, what are we going to look for? We're going to look for a GCF. What does a 25x squared and 81 have in common? Well, guys, unfortunately, nothing. The biggest number that divides evenly into 25 and 81 is 1, and we don't count 1 right now. And they both don't have a variable, so there's no variable you could factor out. So that means there's no GCF. We're going to factor this just the way it looks right now. So again, even though the numbers are huge, I hope you recognize the size of this expression. It's tiny. It's only 2 terms, right? It has an x squared term and a number. There are no x's in this problem. So I hope you say to yourself, wait a minute, could this be the difference of 2 squares? Is this a square minus a square? Well, guys, 25 is a square. He's 5 times 5. He's 5 squared. X squared is a square. He's x times x. He's x squared. 81 is a square. He's 9 times 9. He's 9 squared. So this is a square minus a square. This is the difference of 2 squares. So I know my factors have to match. So guys, whatever you put here and here to multiply 25x squared, they have to match. So I know I'm going to use the x and the x. What numbers match that multiply to 25? 5 and 5. So I'll use a 5x and a 5x to make that 25x squared. Is that okay? Everybody see how it's matching and still getting me that 25x squared? All right, whatever numbers I put here and here, they better match and they better multiply to that negative 81. So what are matching numbers that multiply to 81? 9 and 9. And then what signs do I always need with the difference of 2 squares to make sure that I multiply to that negative number and I get my rainbows to add up to 0? I need 1 to be positive and I need 1 to be negative every time. And then watch, everything's doing its job. 5x times 5x gets me 25x squared. 9 times negative 9 gets me negative 81. And my rainbows, this is going to be a positive 45x, and this is going to be a negative 45x. And they're going to add up to 0 x's in the middle and cancel out. So I wanted you to be aware that some of the ones on Delta Math, guys, they're going to use some pretty big numbers, like 64x squared minus 100. Well, guys, 64 is a perfect square. He's 8 times 8. 100 is a perfect square. He's 10 times 10. So as long as you can recognize your perfect squares, you should be okay. All right, but I do want to warn you that some of the ones on Delta Math, they have some pretty big numbers involved, okay? Is everybody okay with that one? Yes? Okay, well then, all right. We're trying something a little bit different today, and I'm sure you guys are not going to like it, so I am sorry, but we're trying it anyway, just to get a little bit more feedback. I'm not saying I'm going to do this every day, but just to get a little bit more feedback because it's quiet on the Google Meets, and that's okay, I understand. I don't want to put anybody on the spot. I created an exit ticket today. So everybody under classwork on your Google Classroom, you should see it says exit ticket. What it is one Google slide. Everybody got one Google slide where I asked you to factor this, the difference of 2 squares, and I asked you to factor this where you'd have to rearrange and pull out a GCF, and then I asked you guys to rate yourself on a scale of 1 to 10 how good you feel about factoring right now. 1 being that you are mega confused and factoring makes absolutely no sense to you, or 10 being I am so good at factoring right now that I don't think you could give me a problem that I wouldn't be able to factor. All right. So I don't mean to give you guys more work, but just to get a little more feedback, I would appreciate it right now while we double check the attendance. Could you guys try answering these few questions? And I put answer boxes. If you click where it says type answer here, an answer box pops up. Just erase type answer here and you can write your factors in. I don't need to see the work, just your answers. What factors did you get as your answers? Now, because you're my last class and I didn't know how much time we'd have, I gave you guys until 11:30 to kind of answer these few questions, just so you weren't stuck to the bell where everybody else kind of had like the rest of the day to work on it. All right. So I would really appreciate it if you guys would just take a few minutes before 11:30 to answer these couple questions, just to give us a little bit of feedback. All right. Again, I'm not saying we'll do this every day, but it's just something that I might do here and there. All right. We're going to double check the attendance, and then I will let you leave the meet if you want to hand them in. Like after you leave the meet, that's fine. I would just really appreciate you guys doing this Google slide. Okay. All right, Mrs. Greenhouse, are we good with the attendance?
Yep, we're good.
Was it just one?
No, there was 3 people who were
Okay,
absent.
well, we'll figure it out then. Okay.
Yep.
All right, guys. So, thank you so much for coming. I would love for you to finish this exit ticket here. And then there is an assignment on Delta Math. I think it's 7 questions long, and it's all difference of 2 squares. All right. That'll be due tomorrow night at 11:45. Thank you so much for coming, guys. I appreciate it, and have a great day.